activities. I welcome you, sir. And also I welcome all the officials of the Skill Center and also all the participants of the Nirmiti Kendra. You are all represented. Actually, there are 20 plus Nirmiti Kendra engineers are registered, and also a few of the master programs and the MTech program students also taking part to learn something with respect to research and application of this role of chemicals and admixture in construction. I welcome all of you for this special lecture by Dr. Shasikumar R. Before going to the actual talk, a brief introduction about him. Sanath, I'm audible?
Yes, sir.
Yeah.
Yes, sir, you are audible.
This is the brief bio sketch of Dr. Shasikumar R, sir. Dr. Shasikumar R is a seasoned professional with a blend of experience in academia, concrete industry, and consultancy services. And he has had more than 1.5 decades of experience in various sectors of civil engineering and construction industry. He is alumni of PES College of Engineering, Mandya, and also Faculty of Civil Engineering, UVC, Bengaluru University. He obtained his doctoral degree from Visvesvaraya Technological University, Belagavi, and he has done a research on the topic polymer modified hybrid fiber reinforced concrete in his research area. Dr. Shasikumar S. started his career as a senior engineer, Ultratech Concrete, Aditya Birla Group at Bangalore and Mysore. He successfully monitored the quality and post-sale queries of more than 90,000 cubic meter of concrete and special concrete like FRC, waterproofing concrete, very dynamic concrete, temperature control concrete, high strength concrete, and SEC during 2007 to 2010. And he is a distinction of the produce and monitor the quality of first ever commercial SEC in Mysore city for BL Kashyap Private Limited. He involved in many prestigious projects like Mall of Mysore, JN URM projects in Mysore, DRDO projects in Gauripura, Srirangapatna, JSS Hospital in Mysore, Shangri-La Hotel, Bangalore, and other projects. He worked as a senior lecturer at JSS Academy of Technical Education, Republic of Mauritius during 2010 to 13. He also worked as a estate officer for the JSS Academy Limited, Mauritius. He was instrumental in constructing the sports facility and other amenities at JSS Academy Limited, Mauritius. He worked as head of civil engineering department, in charge principal of JSS Academy of Technical Education, Mauritius. He was a member of the BOS of the University Technology of the Mauritius and presently working as associate professor at JSS Academy of Technical Education, Bangalore since 2013 at civil engineering department. He successfully carried out the consultancy works worth of more than 5 lakhs involved in prestigious works, time motion study of RDPR, Department of Government of Karnataka, RDAL, I think. He coordinated a national seminar ride during 2015. Dr. Shasikumar has delivered good number of expert talks in seminar and workshops. He trained cardial engineers on the topic of construction materials quality as per standards. He involved in conceptual planning of JSS Science Tech Park worth of 300 crores. Presently is coordinating the third-party inspection of quality control, quality assurance of cardial works in Bangalore. He published more than 15 articles in the national, international reputed journals. He is also a fellow member of Association of Consulting Civil Engineers, Bangalore, Institute of Valuers. He also a chartered engineer, member of Institute of Engineers, India. He is a certified professional engineering in civil engineering from Engineering Council of India. Dr. Shasikumar S. is a member of professional bodies like Indian Concrete Institute and Indian Society of Technical Education. Thank you, Dr. Shasikumar, for your rich experience will benefit all our participants today. Thank you.
Thank you, sir. Thank you, sir. It's an honor for me.
Invitation. And also, I request you to take over the session.
Yes, sir. Thank you, sir. Thank you very much, sir. See, good evening, one and all. Today I'll be giving a lecture on the role of concrete chemicals and admixture in construction. See, this is the outline of my presentation. We'll be discussing on the concrete and its ingredients, concrete chemicals, admixtures, classification of the chemicals and admixtures used in the concrete, what is plasticizers or water reducers, air entraining admixtures, accelerating admixtures, retarders, special chemicals and admixtures and other chemicals, because it's the family of the chemical used in the concrete is a very vast. And what you call, I'll be touching only the important which we are using very oftenly or very frequently in the construction. Those are plasticizer, air entraining, accelerators, retarders, and there are some special chemicals as well as other chemicals. So, and ultimately my references. See, we all know that the concrete is the most consumed material next to water throughout the world. We are almost consuming some millions of cubic meter of concrete every year, and it is because of its easiness in preparation, construction. We are day to day, its consumption is increasing. So we know that it's a composite material consisting of cement, aggregates, again fine and coarse aggregate, water, and we need to add admixtures whenever we want some specific performances. And late in the 1970 and 1960, we are start using the fibers in the concrete. See, the fibers itself is a very big domain. We have different types of the fiber for different applications, and also to achieve the very dense structure of the concrete, we are using this supplementary cementitious material. It can be we are also calling it as the mineral admixtures, fly ash, GGBS, silica fume, microsilica, lime powder, metacoilin, diatomaceous earth. There is variety of supplementary cementitious material used in the concrete. See, to understand in a very simple way, concrete is a composite material consisting of, in general, 10% by volume of 10% of the volume is occupied by cement, 20% air and water, 30% sand or fine aggregate, and 40% is gravel or the coarse aggregate. This is the generalized what you call composition of the concrete. So whenever we want to have what you call one or more performances or specific performances, today the concrete construction has reached a new scale wherein we will be using the specific chemicals or the specific admixtures to achieve a specific performance. For example, if you want to have what we call color concrete, we'll be adding for our regular concrete, we are adding the color pigment. It can be a red oxide or yellow color, blue color, whatever the color we name, it is available in the industry. See, now the chemical is it has become an integral part of the concrete. Earlier, it was an optional part. Now it has become an integral part of the concrete. So now the expectation from the concrete is increasing day by day. So the next one is what are the concrete chemicals and admixtures? So ACI 212.3, the specification is clearly defining the chemicals or the admixtures as the material other than water, aggregate, cement, and fiber reinforcement used as an ingredient of concrete or mortar and added to the batch immediately before or during its mixing. See, now we have what we call two different nomenclature or the terms, additive as well as the admixtures. See, the word additive, whatever the chemicals or whatever the ingredients we are adding during the production of the cement in the cement factory, we are calling it as the additive. So it can be a calcium sulfate to have the fast setting. Like that, we'll be adding some, even nowadays we are having to produce the PSC or the PPC, Portland Pozzolana cement or Portland slag cement, we are adding GGBS or fly ash during the clinker grinding. See, those are called as the additives. See, now if I want to call a particular substance as the admixture, it has to be added to the concrete during its production. It can be before the mixing or after the mixing. See, next you'll see most of the contemporary admixtures or the chemicals are available in the liquid form. See, when we started using the admixtures, it was in the powder form. So now slowly, because of the convenience, we are shifted from powder form to liquid form. Now it is completely liquid form and all are water soluble. It is completely what you call synchronized with the water for the better performance. See, it is nowadays we started with the individual admixture. Now what you call the expectation from the concrete or the field challenges are different at the different locations. Now, instead of you going for the unique or the individual admixtures, we are going for the system of the admixture, wherein we will go to blend two or more admixtures or the two or more chemicals in general. It can be water reducers as well as the retarders. See, like this, we will go. Now we are in the stage wherein we are mixing the one or more admixtures to achieve the many performances. Many performance. See, the performance may be decreased, the permeability, improved durability, corrosion reduction, slump and workability improvement, pumpability. Pumpability is the one of the essential in the ready-mix concrete, wherein we need to pump to a very good height, high-story buildings. The finish is, whenever we are talking about aesthetic of the concrete, the finish is very, very important. Rheology or the fresh stage performance, alkali aggregate reaction reduction. See, these are all the what do you call the different performance or expectations from the concrete. To achieve this performance or the expectation, we'll be going more than one admixtures in the contemporary concrete production. See, now, before going for the discussion on the concrete, we should know the classifications as per the different codes. What are the different chemical admixtures or the chemicals available to be used in the concrete? So as per the ACI 212.3 R1, it has classified from type A to type G. See, ACI is the well advanced, or it is accepting the field data very quickly. As far as IS concerned, ACI will go to accept the field data, the field feedback very quickly. So you can see here type A, it's simply water reducing admixture, B is retarding, C accelerating. See, now they start mixing what we call two or more admixtures together. See, from D to G, it is water reducing plus retarding, water reducing plus accelerating. See, there is no conflict of the performance. Water reducing itself is a different requirement. Acceleration is a different requirement. So wherever we don't have such complications or conflict, we can continue to mix the two admixtures. Then F is water reducing and HRWR. We are calling it as the high range water reducers. Then the type G is the water reducing. It is also high range. It is retarding. High range means it will going to reduce the water content or water by 30 to 40%. See, this is the classification as well as the ACI concern. Then we have our own IS 9103. It is they have very simple category classification: accelerating admixture, retarders, water reducers, air entraining admixtures, super plasticizer. So the very, very important is we have one more standard, Portland Cement Association, that is PCA EB001. See, this has covered almost all type of the admixtures available in the industry. It starts from air entraining agents to the damp proofing, bonding, gas forming, what do you call anti-washout. It is what do you call include all the different types of the chemicals which are used in the concrete throughout the world. So we can see here corrosion inhibitors are also added, shrinkage reducers are also added, hydration control admixtures are also added. See, we should not confuse with the retarding admixture and the hydration control. Both are having different functions to do. See, this is as per the again PCA EB001. It has what you call the type of the admixture, what is the desired effect, and what are the chemical using. So, for example, coloring admixtures, we need to provide the color. It's a carbon black, iron oxide. Whenever we want gray color, we'll go for the iron oxide. Cobalt, whenever we want blue. Titanium oxide, red. See, these are all the different chemicals used to impart different colors. Similarly, we have foaming agents. This is to produce the lightweight concrete. It is a hydrolyzed protein. Like that, we have different effect and also the different materials. Then, see, you can see here fungicide as well as the germicides. See, we are including or we are spraying on the concrete, see, to inhibit or control the bacterial or fungal growth. See, again, these are the material. Then we have pumping aids, again the chemicals. Like this, for a different what you call expectation or for a different requirement, we are using the different chemicals or the admixtures. This is clearly included in the PCA, Portland Cement Association EB001 standard. See, again, we have super plasticizer. Yes, sir.
I request all the participants to mute. Actually, somebody has Sanath, don't admit. They can use the YouTube.
No, sir. No, sir. By mistake, it was opened. I think it has closed now. Oh.
So shall I continue, sir?
Yes, sir.
Okay, please go ahead. Please go ahead.
Okay, sir. Again, we have what you call in the water reducer itself. See, water reducer, plasticizer are almost same. See, in the we have different varieties of the water reducers. See, it all depends on how much water we want to be reduced in the concrete. See, we are calling it as the free water. See, for example, per cubic meter, if you are adding 160 kg of water, how much I need to curtail? Because we know that less water means more strength. So that is why super plasticizers or the plasticizers are playing a very big role in achieving the required strength. See, these are the classifications. See, based on the what you call amount of reduction. For example, if you want 5, we are having water reducers and accelerator. So we can see here there is an improvement up to 12%. It was very old. Now we are in the stage wherein we can easily achieve up to 30% reduction in the free water. See, now the next one is I will go in detail about the how the plasticizers or the water reducers are influencing on the concrete performance, both in the fresh as well as the hardened state. The plasticizer, again, we will going to categorize them based on their influence on water reduction. For example, if I want to say normal water reducer, it is somewhere between 5 to 8% free water reduction. If I say high range means now we can easily go up to 30% reduction. See now how exactly these water reducers are chemically playing their role in the concrete means. See, whenever we know that cement or whatever the supplementary cementitious material we are using, they are very fine. Their particle size in the level of microns. So as soon as we mix the water with this cement or the cementitious material, it will go to flocculate. Means they will go to attach each other. So because one is water is negatively charged and cement particles are positively charged, they will go to attract each other. So because of this, between the cement particle, the water particle will be arrested or it will be entrapped between the cement particle. So now by adding the water reducers, it may be a normal, mid-range or high range, the main function they will go to do is they will impart the positive charge for the cement particles so that they will go to repel each other. So because of this repulsion, whatever the entrapped water between the cement particle will be released. Say for example, we have added almost 160 or 165 kg of water per cubic meter. Assume that 10 liter of water is entrapped between the cement particle. By adding water reducers, we are going to get that 10 kg of water for the hydration purpose. Whatever the water cement ratio we are calculating, see, we are calculating on the objective that much of water is sufficient for the complete hydration of the cement particles. If the cement particles is holding the water between, that means the free water is not available for the hydration. See, when the free water is released means its fresh property will be improved. See, this is how we can easily think of reducing the free water itself, because all the free water is available for the workability or the whatever the fresh properties, all the free water is available. See, next one, what are the different materials for this under water reducers? It can be as basic as lignosulfonic acid, or the mid one is hydroxylated carbolic acid, and this is the current super plasticizer or the plasticizer we are using, polycarboxylate ethers. This is the whenever we are discussing super plasticizer, it should contain polycarboxylate ether. These are some of the other chemicals which can be used as the water reducers. You can see here sugar acid. These are the organic compounds which will go to reduce the requirement of water. See, the action of super plasticizer include the plasticizer will go to release the entrapped water, but the super plasticizer to some one more extent, it will go to repel. It will go to repel the cement particles. See, so that the cement particles, if you consider the entire concrete matrix, the cement particles are available throughout the concrete, readily available. They are dispersed. Once the cement particles are available, it is the what you call, we can assure our maximum or the 100% hydration will be assured. Plasticizer, they will just release the water. Super plasticizer, in addition to release of the water, it will disperse the cement particle. So next one, what is the effect of plasticizer in general? To some extent, it will also enter in some air in the concrete. It will reduce the water content. This is the basic expectation or the property of the plasticizer. Improve the finishing characteristics, strength. Because of the reduction in the water content, the strength will go to reduce, increase. The shrinkage and the creep, both the plastic shrinkage as well as the drying shrinkage. So the shrinkage is ultimately because of the volumetric changes. So it will go to reduce. Then, so what there is a what you call, we can't always expect the positive effect of the plasticizer. Sometimes we're going to also have the negative effect. So as the what you call all the waters are released because of the repulsive action of the water as well as the cement particles, we may witness bleeding. So bleeding means the water may come out from the what do you call, other material. So we may expect some enhancement in the bleeding, and also because of the usage of the water reducers, we may also witness quick loss. So we expect the workability should last for 30 minutes or 45 minutes. We may lose the workability little early. See, these are all the other effects of the what do you call super plasticizers or the plasticizers. See, I have considered one application case study of the Burj Khalifa. See, in the Burj Khalifa, what do you call, the challenge was to pump the concrete to an height of 606 meters. It is a 606 meter. Pipeline itself is 606 meters. So it has to pump to that such a height, and they are used in different staging. The pumping will going to happen in the different stages. See, for that they have used the different super plasticizer, like the company name is BASF and the product name is Galenium Sky, and they are basically polycarboxylic ether. And the concrete strength was M85. 85 Newton per millimeter square. It has happened for 2 to 3 days continuously, and they are able to pump. It's a world record. The vertical concrete height is the world record, and the pump they have used is the Putzmeiser. See, this is the what do you call, one of the applications are wherein they have used the super plasticizers. We have nowadays, whenever we want more retention of the concrete, and whenever we are going for the high strength concrete, more than M50, the usage of the super plasticizer is inevitable. And whenever we are using the supplementary cementitious material like ultra fine GGBS, silica fume, see, there must be a super plasticizer, see, which will going to ensure the availability of the supplementary cementitious material as well as the cement throughout the concrete matrix. Because ultimately we need to achieve the strength of the concrete. And the meantime, it should be what you call pumpable, or it should have a very good slump retention. See, next one is the very important is air entraining admixtures or the air entraining agents. See, we have some peculiar problem like freezing and thawing. Freezing and thawing is a very peculiar problem we may not experience, but whenever in the polar countries. Sir, I give me a 1 minute. 1 minute. I'll be back in 1 minute. 1 minute only.
Yeah, previous slide, Dr. Shasikumar has explained with respect to Burj Khalifa. I'm very happy to share that one of my BE classmate, Dr. Rajendra Prasad. So he was the quality control in charge of Burj Khalifa, and he was there completion of the projects. And now he has shifted to the Saudi Arabia. Yesterday in the paper, Times of India, actually many of you have seen the tallest structure than Burj Khalifa. It is going to come almost 1/3 or 2/3 work is over out Saudi Arabia.
The Kingdom Tower. Kingdom Tower, it's a Kingdom Tower in Jeddah.
He was my classmate. He is from Tumkur only. See, that is because the lot of infrastructure works are going on with lot of these admixtures. Now I request Shasikumar to take over. No issue.
Yeah, as the professor is mentioned, the structure was Kingdom Tower. It's again in Saudi Arabia, and the place is Jeddah, and the height of the building is 1.1 kilometer. The Burj Khalifa was 880 meter. Now the Kingdom Tower is 1.1 kilometer. It is the highest building because it's not completed. Once it is completed means it will overtake the Burj Khalifa. See, in such projects, usage of the super plasticizer or the construction chemical is inevitable. Because whenever we are designing the high-rise structure, there is a wind effect will be there. That if you imagine 1.1 kilometer, it's not a small height. See there, the concrete has to perform. If the concrete is at the 1 meter, the same performance is expected at the 1.1 kilometer also. See there, to keep up those requirement, usage of the construction chemical or the concrete chemicals are inevitable. See, now the next one is air entraining agents. I was talking about the freezing and thawing. Sorry for the disturbance. Air entraining agents was what you call used or practiced when in the polar countries. Polar countries means where we can witness the freezing temperature. Also, we can witness the 30 or 40 degree temperature in the summer. In the winter, we will witness freezing temperature also. See what will happen when the rainwater or the free water, external free water, when it ingress into the concrete. See, during the summer, it will be in the liquid form. During the winter, it will solidify. It will become an ice. We know that the volume occupied by the ice is greater than the volume occupied by the water. So obviously, it will going to exert because of the increase in the volume. It will going to exert the pressure on the adjoining concrete matrix. See, we are calling it as a pore pressure. Pore pressure will be more. See, after some what we call repetitive cycle, it can be a 50 cycles or 60 cycles. We don't know when it will going to happen. The concrete will start losing its integrity, and we're going to see the cracks. And if it is continuous, spalling will going to occur. Further, if it is continued, delamination will going to occur. See, now to overcome this problem, they have developed the chemical called air entraining agent. It was used in the 1940, 1960 in USA as well as in Canada. First, it was used in the Soviet Union, the then Soviet Union. See, they are artificially, purposefully, they are introducing the non-coalescing billions of microscopic air bubbles in the concrete. See, they're all, we don't know the number, we are calling it as the millions. It is non-coalescing means each bubbles will not attract or each bubble will not coagulate. They are separate. They are positively charged. They are repelling each other. Now, the purpose of introducing these air bubbles or the artificial air bubbles into the concrete is to check that whatever the void created due to the concrete construction, it should be discrete. It should be evenly spread throughout the concrete. See, if the voids are connected together, it will become a fissure, and it will create a channel for the water entry. Water can easily enter, water can easily store there. Then the freezing and thawing will be having the higher negative influence. See, that is why purposefully they have introduced the air bubbles, tiny air bubbles, to check the continuity of these air voids. See, so that they are distributed evenly throughout the concrete matrix. Their size is around 10 to 100 micron meters. Their diameter, we can see here, it's a scanned electron microscope figure. The black indicates the air entrained artificially because of the admixture. See, again, the chemicals are the agents which are salt or the wood resins, detergents, petroleum acids, fatty acids. These are some of the organic or sulfonated hydrocarbons. These are all having this are able to introduce a lot of air bubbles into the concrete. The main objective of using the freezing and thawing is just to check the freezing and air entraining agent, just to check the freezing and thawing effect on the concrete. This is very much prevalent in the polar countries. The effect is increased resistance to the freezing and thawing. See how it is increasing your resistance means the channel for the water entry is discontinuous. It is not continuous. It is discontinuous. Then improved workability. This is the one of the best effect of the air entraining agents. See, in addition to this, what you call evenly distributing the air voids throughout the concrete matrix, it is also acting like a ball bearing for the aggregates as well as the cement particles. Means they can easily slide. So that is why it will go into what you call having the effect of improved workability. Once the aggregate is easily flowing, there will be no segregation, there will be no bleeding. Then it is very much used in the short crate pumping. This is very much required. Then sometimes it is so happened that the compressive strength may reduce because of the introduction of the air voids or the air bubbles. Also, what you call as the air voids are discontinuous, we may expect the reduced permeability. So next one is accelerating admixture. Accelerating admixture again, its usage is very much evident in the polar countries where the temperature is what you call it is around 0 or 3 degree -4. So now we want to accelerate the cement hydration. So it is what you call ultimately using of accelerator will leads to the increase in the rate of hydration, increase in the rate of short on the time of setting. So as per the American Concrete Institute, it will also leads to the increase in strength. See, whatever the chemical using as the accelerator can be grouped into 4: soluble inorganic salt, soluble organic compounds, quick setting admixture, miscellaneous, solid admixtures. See, these are all the what you call the different groups of the admixture. Under inorganic salts, we have chloride, bromide, fluoride, carbonates, and what you call the commonly used accelerator is the calcium chloride. Commonly used one is the calcium chloride. See, it is not having the usage only in the polar countries. Wherever we want to have the what you call early removal of the formwork, or wherever we want to achieve the multiple usage of the formwork in the case of the precast industry, there also we are using the accelerators. So then what you call the effect due to the accelerators, it is what you call reduced initial and the final setting time such that we can finish the concrete very quick in the polar countries, or we can reuse the formwork, or we can stripping time will get reduced. The formwork stripping time will going to get reduced. The compressive strength will going to increase in the early ages. See, whenever we want to have the bridge tech beams or the bridge retaining walls, wherein we need to allow the traffic very quickly, there also we will be using the accelerator. See, because of usage of the accelerator, we will also witness some what do you call unwanted effects like increase in the volumetric changes. It can be a shrinkage in the form of the shrinkage, or it is also ultimately leads to the, because we are using the chloride accelerator, it can be calcium chloride or any other chloride. So because of this chloride in the presence of water, the hydration process byproduct includes water also to some extent. If you are already having the chloride inside the concrete, it will leads to the formation of the hydrochloric acid. See, the concrete strength is completely depends on its pH. If the pH is near to 14, if the concrete body is completely alkaline, then it is having a very better protection against the chemical or any other attack. But you are using the chemical called calcium chloride, and the hydration product includes water. Water plus chloride may lead to the production of the formation of the HCl. Ultimately, the alkaline environment of the concrete body will convert it into acidic. See, when the concrete body is become acidic, it is susceptible for the chemical attack. See, particularly sulfate attack. So this is one of the what we call unwanted effect of the accelerator, and also corrosion of the metal. Again, when the alkaline concrete has converted into acidic, obviously the steel passive layer. Calcium hydroxide is which is also a byproduct of the hydration process, which is responsible for maintaining the alkaline environment in the concrete. But because of the purposeful inclusion of the chloride accelerators, the calcium hydroxide effect may get reduced. Ultimately, the corrosion may happen. See, the applications reduce placing and finishing time of the concrete, early stripping in the precast industry. See, there also we are using the accelerators. See, next one is retarding admixtures. It is exactly opposite. See, whenever we are doing the concrete construction under high temperature, 40°, somewhere in the Rajasthan, we have about to touch 50°. See, there, because of the what you call ambient temperature, the concrete, the cement may what you call hydrate very fastly, and it may gain the strength very early. Means we need to have some time to work with the concrete. We have to mix, we have to transport, we have to place, then it has to start sitting. See, but because we require minimum 30 to 45 minutes for a concrete to produce, then to place. If you don't have that much of time because of the ambient temperature, what you call it may lead to the reduced performance of the concrete. So for that, we need to use the retarders. In the what you call tropical countries where the temperature is very high. See, the purpose is delay the setting of the concrete. So now what you call too much delay means it will going to alter the early strength gain of the concrete. See, we have to balance. We have to balance. Then what you call even in the grouting of the retaining wall or any other structure, there also we are using the retarders. And whenever we want to finish the concrete, so nowadays we have paver finish to have the even for the CC roads also we have paver finish. The paver finish till the paver is complete, the top surface of the concrete should be workable. Otherwise, they can't finish the concrete. So there are different methodology like adsorption, nucleation, complexion, and precipitation. All this what we call different methodology or the concept of the retardation is included. Once we add the retarding agent to the concrete, it will going to create a passive layer around the cement particle. It will prevent the cement from mixing with the water or reacting with the water to some extent. To some extent, after that, the passive layer will be diminishing, and the cement particle will start reacting with the water. Then the hydration will going to start. So this is the main what you call principle behind all these four different methodology: the adsorption, nucleation, complexion, as well as the precipitation. See again, what are the different chemicals: lignosulfate, hydroxycarbolic acid, phosphate, and the sugars, borates. These are the different chemicals used as the retarding admixtures. Then effect, care must be taken, otherwise we'll end up in the reduced compressive strength. Then it may increase the initial slump. See, the main objective is to keep the concrete workable for longer duration. See, because of this, the initial slump may high. See, what will happen when the water is not consumed, when the water is not used in the hydration process and the free water is still available, it may lead to the bleeding of the concrete. These are all the unwanted effect of the retarders. So that is why care must be taken. In all the admixtures, a thorough trial mix should be done to tune up the dosage of any type of the admixture. A thorough whenever we change the material, or whenever we change the aggregate, or whenever we change the cement type, we have to conduct the trial mix. See, the compatibility with the cement and admixture is very complex. We need to achieve that first. Then we have to check the compatibility with the other ingredients of the concrete. That is why trial mix is the very best way to identify the required dosage of any admixtures. Also, it may delay the rise of peak temperature due to hydration. Plastic shrinkage may slightly increase. See, when the hydration is not started and the concrete is still in the wet condition for longer duration, the concrete surface may witness some plastic shrinkage. See, next one, these are the, what you call, we started with the super plasticizers, air entraining agents, accelerator, as well as the retarders. See, these are the most commonly used admixtures. This may be used as the single admixture or the combination of the admixtures. See, nowadays, as the requirement is increases, as the expectation from the concrete is increases, we will have some special chemicals of the admixtures. See, one such is the lithium and silicate based intensifier. So whenever we are, what do you call, constructing any factory building, office building, see, the factory and the office building are having more movement. Even in the factory, we have movement of the vehicles, and even in the office, movement of the people will be very high. See, what will happen if you want to keep the concrete floor as it is, you don't want to put the tiles, or if you don't want to put the granite material and keep the concrete as it is means, so what will happen once we, what do you call, do all the placing, vibration and everything, after hydration, the being a lighter material, the calcium hydroxide, which is the byproduct of the hydration, will come out to the surface, and which is stable. Because of this movement, abrasion, it will come out of the concrete. See, the surface will become more dust. See, to avoid all these things and to keep the concrete, the structure or the surface as it is, we are using the densifier. See, I want to show one video. 1 minute. I'll show one video. One minute. Sir, Sanat sir, is the video is visible?
Yes, sir. Yes, sir.
Yeah.
I think the video is muted. Just audio is muted.
Processing
Yeah.
facilities and wineries. With BHARAT.
The densifier is it can be lithium or silicon based one. See, first what they will going to do is they will going to grind the surface. Any loose material or any dust will be come out first. Thereafter, they will going to spray this densifier. Then what do you call? Again, they will going to do the grinding such that the densifier will penetrate into the top some millimeter. See, we can see it's like a mirror. It's like a granite material. So this is the application. Yeah, this is the grinding process. See, if you want more, what you call, luster, or if you want more shining, you need to grind. I hope you remember in earlier days, this was used for the what you call mosaic tiles. Similarly, they will go to do. But ultimately, it will impart a very what you call good hard surface. See, these are the different companies. Yeah. Yeah, we'll back to our presentation. This is what do you call? It is chemical react with the remaining calcium hydroxide such that the concrete surface will become solidified even after the if the vehicles are moving or the machines are moving, the surface will heat. So it will increase the. So next one is the special. So whenever what do you call it depends. See if our concrete element thickness is very less and its exposed area is very high walls, the curing or the ensuring the effect to use the road very quickly, then application of the self-curing compound is inevitable. Glycol ether. See here it will go to prevent. See, as I told in the beginning, whatever the water content we add or whatever the water cement ratio we have added, it is just sufficient for the hydration of all cement particles. See, the main purpose of curing, it can be any type of the curing, is just to ensure that whatever the free water added during the concrete mixing should not escape in the form of the evaporation. So now with that objective, instead of what you call going for the pond curing or the gunny bag curing, the road construction or the retaining wall construction, they are spraying the self-curing compound. So which will provide a what do you call a layer wherein whatever the water added to the concrete will not going to escape in the form of the evaporation. See again, one more video is there. I'll show that. One minute. It's open, but it's blocking. So, Sana sir, how to push this bar up? Because I can't see the tabs.
Sir?
Can you guide me? I want to push this tab, that mute to start video, because I'm not able to. 1 minute.
Minimize, sir. No, you can go for share.
Share, but 1 minute.
You have to share another. Yeah, screen
I
sharing.
want to share another video.
1 minute.
No, this rigid.
Because I'm not able to.
Rigid payment.
No problem. No problem. No problem.
Sir, it is next tab. Rigid payment.
No problem.
Okay.
Yeah, but I'm not able to see here. No problem.
We are able to see that screen now.
We can see.
Now it is screen is visible, sir.
Yeah, visible.
Yes.
But audio is going. It to open.
This
Video file it to open. Yeah. Now we are able to see.
Yeah.
You can adjust your.
See, this is the road construction wherein the labor is spraying the self-curing compound. See, when we apply the self-curing compound, there is no necessity of gunny bag curing or pond curing. This self-curing compound is providing a protective layer for the moisture to it won't allow the moisture to escape, and it is not having any what you call side effect, or it won't change the surface hardness. No such side effects. Yeah. So this is the one small video. We'll go back to our presentation. See, this is what you call very useful chemical. Whenever we have ambient temperature is too high, and whenever there is a high chances of early escape of the moisture, usage of the self-curing compound is inevitable. Now we have the mega construction happening in India, Delhi to Bombay expressway. There they are completely using the what do you call the self-curing compound, and it is in the spray. It is in the spray. Now they are having the what do you call target of achieving the 2 kilometers per day. So when they are having such a big target of 2 kilometers concrete road per day, then where's the question of curing? It is just what you call spraying the curing compound and move on. See, not only in the road, we have retaining walls, also deep footings, where it is highly difficult. Not only roads, wherever it is highly difficult to cure the concrete element, we'll go for the spraying of the self-curing compound. And one more agent, foaming agents, which is also a chemical. We are also calling the concrete produced by using the foaming agent as the cellular concrete. It's a very simple concrete wherein we are using cement as well as the fine aggregate, no coarse aggregate. And the density we are keeping less than the 800 kg per meter cube or less. It is highly porous, it is highly lightweight. Say our regular concrete is weighs somewhere around 2,300.
Dr. Shasikumar, some audio issues, some network issues, sir.
It's almost.
Hello, Shashi?
Yes.
Hello.
No, sir. It's. Am I audible, sir? Sir, am I audible?
Yeah. Now it is clear. Now it is.
Okay, sir. Okay, sir. Okay. Now we are talking about the foaming agent. Foaming agent is the what do you call new age chemical to be used in the concrete. Though we are not using the coarse aggregate, the ingredient includes only cement, water, foaming agent, as well as the fine aggregate to some extent. And our main requirement is to produce the concrete having a density less than 800 kg per meter cube. If you compare our regular concrete, which is having the density of 2,300 to 2,500 kg per meter cube, it is very less. Wherever we want to do some infills or instead of soil filling, if you want to do concrete filling, the foaming concrete is the one applications. And one more thing, in the factory building, wherever we have the sheet roofing, to achieve the temperature comfort inside, we will going to apply the foaming concrete on the factory buildings. See this with some small reinforcement of 4 mm mesh, we will going to apply the foaming concrete. This will going to provide the required thermal comfort. If you are using only the zinc sheets or JSW or any other company zinc sheets, the heat will be completely transferring into the factory building. Wherever we have some factories where the inside temperature should be maintained within some 30 degree or 35 degree or less than 30 degree. See there, the sheet roof can be covered with foamed concrete, and we know the what you call lightweight bricks also. This is the extension. See here, during the mixing of the cement and water, we are adding the foaming agent. So it will also create a lot of air bubbles so that its weight will come down. There is no coarse aggregate in the cellular concrete or the less weight concrete or the lightweight concrete. See, this is gaining momentum, and it is usage is increasing slowly. See, next one is,
just to add your application in L&T, all the infill walls are this concrete only nowadays.
Yes, sir. Yes,
all
sir,
the
yes,
L&T structures have visited few buildings.
Yes, sir.
Infill structure, they are not going hollow block. They are going with only separation with this application.
Yes, sir. Yes, sir. Yes, sir. And also it will go on to reduce the load on the building to a greater extent.
Yeah.
It is 2,300. Where is the 2,300? Where is the 800? It's almost 1,700, 1,800 less. So it's a very great saving in the design. It's a very best example the professor has mentioned. And in addition to this, we have other chemicals which are used in the concrete. It can be a flowing concrete. So now we call slowly the concept of site mix is slowly we are moving out of the site mix concrete. We are going for the ready mix concrete. We will just order, they will bring, and they will finish. So, for example, if just for the information, if you are going for the site mix concrete with all the equipments, with all the ingredients and all the labors, we can achieve 28 meter cube. It's a study. We did 28 meter cube per day. Per day means 8 hours. 8 hours. So now if you are going for the ready mix concrete, 28 meter cube we can achieve in 45 minutes. See, that is why wherever in the city environment, wherever we don't have space to store the material and we don't have time. Earlier it was a one-day affair. Now it is a 45 minutes or 1 hour affair. See there, now to achieve the flowing of the concrete, I have gave the example of Burj Khalifa, where the world record as on date was 606 meter. See, the concrete has to flow like a water. To achieve that, we need to add a combination of the admixture. It can be air entraining agent, water reducers in the form of the super plasticizers, retarders. See, it is a combination of the admixtures. See, now it is completely, if I say it is a flowing concrete as per ASTM C1017, it should have the slump more than 190 millimeter. And the flowing concrete is completely depends, or it's depends on the, it's a function of the type of the construction, time interval, availability of the admixtures, ambient temperature. See, these are all the different parameters on which the admixture usage in the flowing concrete is depends. See, now for your information, I will share one more video which I was involved in way back in 2009. As I mentioned, as the sir is in the beginning told, I witnessed the first commercial production of the SEC in Mysore city for Mall of Mysore. If you ever visited Mysore, you could have come across the Mall of Mysore just opposite to Mysore Zoo. There is a seven-star hotel. The entrance of the 7-star hotel is 3 roof height, means 30 feet height. So now we had a challenge when I was in Ultratech concrete. We had a challenge to pump the concrete to that height. Number one. Number two is, if you see the video, you're going to understand the width of the beam is 1.5 meter. The depth is 1.8 meter. The beam. And we have a challenge of providing the concrete to such a congested reinforcement. Then we suggested a SCC, a self-compacting concrete of grade M35. And we use the viscosity modifying agent. We use the super plasticizer, and also we use the fly ash. So these are the different admixtures we have used in the production of the concrete. And you can just go through this. Yeah. You can see the concrete is really flowing like a water. And also you can see the congestion of the reinforcement. This is the concrete is flowing inside the beam. This is a beam. One beam has took almost 50 to 40 meter cube of self-compacting concrete. So you can observe the concrete is flowing like a water. So it's nothing but it is a SCC, it is a self-compacting concrete. And the very important thing whenever we are supplying or whenever we are pouring the self-compacting concrete is the formwork. See, we expect as a concrete producers, we told the client was BL Kashyap, and we told the BL Kashyap that the formwork should be waterproof. Waterproof. It's like a cylinder, or it's like a water tank, and also it should sustain the load. Concrete is not sitting for so many minutes, and it is flowing. And it should also take the load. 1.5 meter by 1.8 meter, it's not a small, dimension. One minute, I will just move the. See, we need to do some checking for every batch of the concrete. Yeah, at that time, the instruments was not so advanced. We have used the whatever the material available at the site. This is the flow table test. So we can observe that the coarse aggregate is not only in the core of that particular circle, the coarse aggregate has traveled to the periphery of that particular circle. See, this is possible only with the usage of the air entraining agents as well as the viscosity modifying agent. See, now what you call we are not checked only at the site, we are also checked at the plant also. We did the V funnel test as well as the flow table again. It's a very sensitive concrete, very sensitive concrete. We should not mix, the mixing time should not be more than 30 seconds. If the mixing time is more than 30 seconds, even though you added the air entraining agents, it will lead to the burst of the air bubbles. The air entraining agent is not having any effect. The care must be taken, even the mixing time also. See, this is in the plant also, we have checked and we have supplied altogether 355 cubic meter over the period of 2.5 days, continuous. See, this is very, very important. The flow of the coarse aggregate to the periphery of the circle. It should not stagnate only at the middle. Also, we have checked the V funnel. Yeah, this is the top view. Yeah, this is the V funnel test. See, this flowable concrete or the SCC is having different requirement. Fillability, flowability. Flowability means it should be able to pass through the reinforcement. Fillability means it should fill each nook and corner of the formwork. Like that, we have different requirements. It is not a single requirement. See, now it should have passed within the 10 seconds. Entire concrete in the V funnel should have passed in 10 seconds. We achieved somewhere around 8 seconds. Yeah. So we'll go back to our regular presentation. See, apart from the what you call the special as well as the other admixtures, we have what you call different chemicals as well as the admixtures, which are very much useful or which are very much required whenever we are going for the repair of the concrete. See, for example, rubber latex. If I want to mention the rubber latex, it can be a natural rubber or the artificial rubber. Nitobond is the one such example which is marketed by the Fosrac company, which is having the styrene butadiene rubber latex. We're calling it as the SBR latex. See, we are using this polymer in the concrete. See, now the polymer, it's a rubber latex is a polymer. Latex itself is a polymer. See, usage of this polymer in the concrete is having many advantages. See, for example, we know that in the world, if you take any compound wherein if you mix the water, ultimately it will be having some air voids in it. See, it is inevitable. Concrete, water is must and it is inevitable. See, now why air void is there? Now usage of this rubber latex, what will going to happen? This rubber latex will going to fill that particular air voids. See, the air void is not what you call empty or it is not free. If it is empty means the foreign free water may come or the foreign chemicals may attack or they may get into that. But this is filled by the polymer rubber latex. Well, this is the one advantage. And another advantage is it will going to improve the ductility of that particular concrete element. So, for example, if some beam is cracking at 110 kilonewton, means the beam with polymers or the rubber latex will going to crack at 140 kilonewton. Like that, it will also improve the ductility of the concrete. And also we have viscosity modifying agent. This is very much essential whenever you are going for the self-compacting concrete or the self-consolidating concrete. And we had one more project in Bangalore, construction of the houses for the police quarters. So where the entire building is SEC. SEC means they have categorized them into SDC as well as the SEC. As per them, if it is a SDC, you should have used the 20 mm. See, SEC, generally we are not using the 20 mm. The maximum nominal size of the aggregate is 12.5 down size. But SDC, they are insisting us to go for the 20 mm. For wall and all, they will be using the consolidating concrete. And for the slab, they are insisting the SEC. See, again, it's a different combination. There, the usage of even though we have used the super plasticizer, but usage of the VMA or the viscosity modifying agent is inevitable to have the very good consistency. VMA will going to reduce the bleeding. It will improve the flowability of the concrete. Then we have permeability reducing admixtures and the bonding admixtures. I gave the example of the polymer. Whenever we want to lay the new concrete over the old concrete, so we need to apply this bonding admixtures such that it will going to ensure the proper bonding with the old surface as well as the new surface. Then we have what we call integral waterproofing compound. Integral waterproofing compound means we are mixing during the concrete production. See, we have waterproofing options. Once the concrete, for example, slab is over, we can apply the waterproofing compound over that. But if I say it is integral, means I should have used that during the concrete production. So now how it will going to affect means, again, it will going to densify the concrete. The concrete matrix will be more denser, less air voids. It won't allow the water to penetrate. See, the best example is Riomac from BASF again. See, again, we have admixture for very high early strength concrete, very much useful for the concrete deck beam or the deck girder beams for the bridges or the flyovers. You need to remove that in the next day. And you have to lift the girder beam or the deck beam in the next 7 days. So there, if I design it for the M40 means in 7 days or 3 days, the 40 should be achieved, so that I'll be easily handling that particular entire concrete structure. So there we are using the admixtures. We have shrinkage reducing. There is one more. We discuss here entraining admixtures. There is a reverse here detraining admixture. It will take out the air content inside the concrete also. See, like that, coloring admixtures, we have earlier we used to go for the tiles. Nowadays, the concrete is coming with the color. It can be, we discussed in the beginning as per the PCA EB001. If you want a gray color iron oxide, if you want blue color, it is again different chemical. Like this, different color, different chemical. So now, care must be taken whenever we are using the coloring admixtures. Care must be taken that the coloring pigment should not alter, should not affect our regular hydration process. So ultimately, if I say concrete means after 30 minutes or after initial set should be over, after 9 to 10 hours, final set should be over. Adding this additional coloring pigment should not alter, should not affect the regular hydration process. See, any admixtures or any chemicals which are the integral part means used during the production of the concrete, they should have a common objective of they should not alter, they should not affect the hydration process. See, like that we have many chemicals. If I say chemicals, admixtures means it should be mixed during the production. If I say chemicals means it's very wide. if you are going for the underwater concreting, we have different chemicals wherein the tramming method was used and it should be set as soon as possible. Whenever we are going for the pile foundation, concrete should set very early so that we can lay the foundation on the piles. Like that, we have a n number of what you call admixtures available and the chemicals are available to improve the one or many performance of the concrete. See, these are the references I referred. Hope what you call my presentation is useful to you, though it is very short. I think I have covered most of the admixtures. If you have any questions, it's open, sir.
Yes, we are happy. Your presentation is excellent, and also slide preparation is good.
Thank you,
This
sir.
is
Thank you,
the
sir.
need of the hour for all the construction industry people to take care of. Always, you should not rely on only the what you say this conventional concrete. There are various types of concretes are there. How to make a good concrete, bad concrete only in our hand. The concrete ingredients are same. The making procedure you have to adopt very properly. I request all the construction Nirmiti Kendra engineers, please download IS 516 also. And also they are given clearly the procedures and also where what are the procedure concrete making techniques. The code books are available. What are the various process involved? Just to adopting good process technology, you are able to achieve very good concrete. The job of the concrete is to protect the steel. If you are not making a good concrete, your building will not durable. See, IS 456-2000, what is the theme? I think we all know that the theme of the code book is durability of structures. Because the structures are not durable, what we use the code book of 1978, what I used. See, during my course of time, IS 2000 also experience, make a durable concrete. If the concrete is durable, your structure is durable. Now I request all the participants, any questions are there with the speaker? There are two questions posted, I think, chat box. Sanath, just read the name of the person, chat box.
Rohit.
You can just say, take the question.
Sir, you can what do you call, tell the question. I will answer that.
Yeah.
Cost of self-curing compound more than simple curing compound. How much price variation is in it?
Yeah. So obviously, still we know that water is the very cheaply available and easily available curing aid. But whenever the situation or the site condition is not supporting, see, there we have to go for the self-curing compound. That is the number one. When it comes to the cost, yes, it is always 10 times costlier than the water cost. It's somewhere around per liter. It is, if I'm not wrong, it is 180 rupees to 200 per liter. And we are not what you call applying. We have to mix that with the water for its easiness in the spray. And yes, what you mentioned is it is obviously it is costlier than the water.
Yeah, actually, it is nothing but a membrane curing. Whenever you
membrane curing.
Yeah, membrane curing technique is a new technology. See, actually, because whenever the area of surface is very more, then we cannot do ponding. And also, he has been rightly mentioned during his presentation, the area export the volume of concrete very high, especially slabs, runways, airfields. See, actually, it undergo plastic shrinkage cracks. Once the cracks are formed, it is very difficult to repair. These cracks will appear within after finishing final setting of the concrete. You can see all this map-like crackings. To overcome this type of cracking, and whenever the large area you have to do curing, it is advisable to go with a membrane curing or a spray curing. See, the spray curing is nothing but a membrane curing technique that can be adopted depending upon the type of the projects. See, generally in the projects wherever the fast track construction works are going on, because India is making a record break, the construction of roads, whether you take a bituminous roads or a concrete roads. Without technology, we cannot go fast and we cannot make a record break without compromising the quality. Next question. Sanath?
No, sir, no questions.
Yeah. So, and also just to add to Dr. Shasikumar R's input, he has given air entraining admixtures. There's a lot of research is going on in IIT Madras, even many developed countries, how to produce a lightweight structural concrete. The lightweight we can produce using air entraining admixture. It is also called as a aerated concrete. But now the research work is going on how to make a structural lightweight concrete. If anybody interested to do further research, this is the topic you can take up, how to design a lightweight structural concrete. A lot of research is going on. Many countries already produced it and they're already implemented. This is for the scholars, research scholars who are all joined. See, today aerated concrete is one of the upcoming area, especially wherever, say, Bangalore is subjected to waterlogging. What is the solution for this? Aerated concrete. The aerated concrete will allow the flood water to go to the drains. But here they are using only 25 MPa concrete for all the BBMP works, what we observed. All the drain covers, even everything made up of concrete, no water will go inside sometimes. Therefore, parking lots, shoulders, if you encourage aerated concrete, definitely the 50% of the flooding can be avoided, because few of my PhD students done aerated concrete as a part of the application for parking structures, because only thing is the structural effect, we have to see that. Without compromising the strength, we have to design aerated concrete. Yes, actually, I'm very happy and thank you, Dr. Shasikumar.
Thank you, sir. Thank you, sir. Thank you, sir.
Within no time, you are accepted our invitation. You are justified and presented very well. Now, I request all the Nirmiti Kendra engineers try to adopt some materials to make a good durable concrete, because the durable concrete is very, very important for the structures durability. See, without using all these chemicals, we cannot do fast tracking, we cannot do durability. Even in the laboratory, we are able to produce up to 50 MPa concrete without admixture. If you want more than 50, it is required. And also SCC concrete, what Shasikumar has told, I think 2009. Now the aggregate size is also coming down, as I told, to 14 mm. I think, I don't know whether you use 20 mm down size in 2009.
20 mm was used in one of the projects, sir.
Yeah, because of now,
it's restricted only to 15% of the total aggregate.
Okay, okay. Yeah, you presented very well. Thank you once again. I request.
Thank you, sir. Thank you. Thank you for giving me an opportunity.
And also, I request Director Sir is there. Sir, any questions from you, sir?
Good evening, sir.
Good evening.
Professor Shasikumar sir, good evening.
He is a blending of experience, both academic and industry, sir, actually.
Correct. We should know all these things. Because,
Yes, sir.
It's an innovative approach. Thank you, sir.
Thank you very much, sir. Thank you, sir. Thank you for giving me an opportunity. Thank you very much.
One question is that.
Yeah. Please take.
Which chemicals are used for self-curing at high structures?
High-rise structures.
High-rise structures.
Okay.
High-rise structures.
They have put only high structures. Okay.
High-rise only. High-rise structures only.
High-rise structure.
Yeah.
See, the question, the thing is, see, we will go for the usage of the self-curing compound wherever it is not possible to cure the conventional method.
Yeah.
It can be a ponding or gunny bag covering. See, high-rise structure, it is above the ground. We can easily access. And also self-curing compound usage is whenever the concrete element is having a very exposed area and very less thickness. See, these are all the advisable areas where we can use this self-curing compound.
Even BMRCL, all the RC elements and deck slab elements. If you see the tunnel element, I personally visited previous visits. See, within 8 hours, they are able to produce a tunnel lining elements of within 8 hours. There are 3 shifts. The tunnel elements of 6 to 7 elements, including key element, they are able to produce 50 megapascal in 8 hours.
Steam curing, they are going for
steam curing. It will go to the steam chamber. See, we are planning to take all the engineers. Just you can see that what is the type of mold they are using, how they are casting, how these elements are moved to the steam chamber. Within 8 hours, it will come out. But actually, if you go to the stacker, a lot of stacking is going on because delay in boring. It will numbers are put up more in stackers. That also we observed. Any other questions?
See, the concept, just to add to the professor words, the concept of steam curing, we are calling it as accelerated curing. See,
Yeah.
whatever the strength you are supposed to get at the end of the 28 days, you can expect that at the end of the 24 hours.
Yeah.
See, that is the main objective of this steam curing. When it comes for the high-res structure, when it is not possible to go for the conventional curing, yes, whatever the polyglycol I have suggested, which was used for the pavement, can also be used in the high-rise structures.
See, only in India we are using concrete mix without fibers. If you go to European countries, fiber is a must. There are different types of fibers are used. Fiber reinforced concrete is the concrete for them, and also just to free from any cracks, they don't want to take risk. See, sometimes they'll use the double fibers that is called hybrid fibers. But still in India, the core books are not updated. So wherever in a special application, try to concentrate on fiber reinforced concrete. See, it is make a concrete ductile behavior. See, generally wherever the earthquake resistance is required for structures, sometimes we are using fiber reinforced concrete. Just to make the concrete to ductile, because we all know that the concrete is a brittle material, it will fail without symptoms. Suppose I want to see a failure with symptoms, then I have to add some fibers. Even the Recron 3S fibers are available, both plastic and concrete. See, these fibers also one of the next ingredient. It is after the mineral chemical what Shasikumar has presented. It is an additional ingredient, especially in many industries. He has shown some densifiers. In some cases, instead of densifiers, they are using fibers itself as a floor, one of the concrete mix. Because we executed one Suzlon, the wind turbine industry in Coimbatore. They want 50 to 50 MPa fibers of 50 megapascal without reinforcement. I have seen white topping and Bangalore going almost, they are going with a big way of steel reinforcement. Making the steel reinforcement is very costly, but instead of that, they could have gone for fiber reinforced concrete. If anybody wishes to visit IIT Madras, so all the IIT Madras recently laid concrete roads are made up of FRC concrete only. This was just, I'm sharing the information for the this gathering. And thank you once again for all the participants for patience hearing. Thank you, Shasikumar, once again.
Thank you, sir. Thank you, sir.
And also I'll thank our director, sir, for his presence in this seminar. And also I'll thank Sanat Kumar, not least because you are the backbone of all online programming. And thank you once again. And also I'll thank all the MTech CT students and also CMTA trainers and also all project directors, Nirmiti Kendra engineers for your participation and involving in discussion. Thank you once again to all of you. And also I request all the participants who are all interested in certification, please give our feedback. And also all the Nirmiti Kendra engineers fill up the feedback for the attendance purpose of the stream. Thank you once again.
So Sanat sir, shall I exit?
Sanat?
Okay.
Sir, yes, sir.
Yeah.
Okay. Okay. Thank you very much, sir. Thank you.
Thank you, sir. Thank you.
See, tomorrow again, there is a special guest lecture by L.R. Manjunath. He is also a sitting Indian Concrete Institute chairman and also vice president of Direct Sales Sustainability Initiatives. He is going to talk